look at another absolute value inequality problem. So notice that in this inequality there is no equal sign. It's just the absolute value is greater than 3. Which is a little different than when we worked this problem out, and that we had that equal bar right there. So when we're doing this in our calculator, we're going to want to use a different inequality. We're going to want to use inequality that has the equal bar there, because then it's going to give us our end values. If we don't put that equal bar there, then we're not going to get our end values. So let's just go ahead and graph this. So we're going to graph it the two different ways. We're going to put this in as we see it. So we're going to do math, number, absolute value, 2x plus 2. Oh, it's not writing. Let's try this again. Math, number, absolute value, 2x plus 2. And then we have to go outside our absolute value, or close your parentheses, and then do minus 1. So now we need to put in our inequality. So we'll do second math, but instead of picking number 3, we're going to pick number 4. Our answer is still going, we're still going to use that inequality in our answer, but for the sake of graphing, we want to have that equal bar in there, or we'll get the wrong answer. Now we're going to put in number 3. So we're going to go ahead and graph it. Okay, so we can see that, remember, for this kind of graphing, 0 means no and 1 means yes. So that means that everything less than, I believe that's -3, and everything greater than 1 is going to be our answer. So we can push trace, and remember, when y is 0 for this kind of problem, it means no. So I go, oh, there I am. I'm at -3, -4, -5, and you notice all the values in between. See all those decimals? So it's everything. And then I can go the other way. So I'm going to bring it over this. Those are all no's, and then I can go the other way. So notice this at 1, 2, 3, and all the numbers in between are yeses. I can go look at my table, second table, and I can see that, look, where we start at -3 is a yes, and everything smaller, but when I get -2 is a no, and I can go and I look, and then it doesn't pick up again to be a yes until I get to 1. The reason why when we put it in our calculator we use this symbol is because if we didn't and we looked at our table, we would miss out on the answer of -3, and we would miss out on the answer of 1. So we put that in for that reason. So let's go back and look at our graph again. So this is where x is less than -3. So I'm going to write that here. X is less than -3. Or x is greater than 1. That was on the other side. Okay, so let's look at this on the xy coordinate plane. And you might be saying, well, why? That's confusing. Because you might see it on the xy coordinate plane and you need to recognize how to get the answer. Or you might be asked to graph it and show what the answers are. So we're going to delete this inequality and the 3. Oh, actually, you know what? I actually wanted to leave that there. So I'm going to show you something else. So what am I doing? Second math, that was greater than or equal to 4, and then we had 3. Okay, I'm going to leave that one there, but I'm going to turn it off, and there's a reason for me to do that. And then I'm going to put in the absolute value of 2x plus 2, and then go outside the absolute value minus 1, and then for my y3 equals 3. So remember, I got to switch the little flappy thing over here so that I'm looking for all numbers bigger than 3. So that means I got to change that flappy thing so that if I imagine this to be a square right here, that's on the bottom of the square, I want it on the top of the square because tops are bigger than bottoms. So that means I'm looking for a number bigger than 3. So I'm going to go ahead and graph that. So that's my absolute value, and then there's my 3. And that's all bigger than 3, isn't it? So let's think about this. This is where y is 3, 4, 5, 6, 7, 8, 9, 10. So it gets shaded above it. Okay, so my answers live where the absolute value is shaded, and my absolute value is shaded there, and my absolute value is shaded there. It's in the shaded region, yes? So that means I want everything, my value of x from here out, and my absolute value from x from here out, because I'm looking for my x values. So I'm going to put up what I had before. Let me enter this in, and it might make it a little bit clearer to see. So you can see where that blue, this blue line, is directly beneath, it's like a shadow of the part that's in the shade, okay? And here, this blue line is in the shadow of all the region that's in the shade. So these two graphs mean the exact same thing. So I could get my intersection here, and I would go second, trace, intersection, which is 5. I'm going to move over, oh, look at, oh, this is a good lesson. So notice where I am right now. I'm on this y1, which is down here. I want to be on the absolute value. So I'm going to move my arrow up. I moved my arrow up. Notice that I'm on y3, so now I'm here, which is good because I want the intersection between y is 3 and this absolute value. So I'm going to push enter. It jumped back down there. I don't want it down there. I don't want it on that line. I clicked my arrow twice, and now look where I am. I'm on my y2, and that's where I want to be. Oops, messed up. So now I'm going to move my cursor close to the intersection. I push enter, enter, and I get the intersection of -3. So notice that if I were to trace this, let me go up here. Let me make sure I'm on the right. I'm on the equation I want, my absolute value. If I trace that, notice my values of x are getting smaller than 3 as I go up. My value of x is getting smaller than 3 as I go up. Okay? So it's all that region there. So my value of x is getting smaller as I trace that absolute value sign, which is the same as being in the shadow. I'm looking at my values of x. So let's go and do this side over here. Second trace, intersection, which is 5. I don't want to be on that line, so I'm going to move my arrow up. Now I'm on my line y equals 3. So I'm going to move closer to where I want my intersection, which is over here. I'm going to push enter, and it went back down to y1. I don't want y1, I want y2. So I'm going to push down again. So notice it's on y2 now, just my absolute value. It's really close to my intersection, so I'm going to push enter, enter, and look at, I'm right there at at x equals 1. So what values of x do I want? Well, I want the values of x that are in the shaded region. So let's just trace, and this thing just keeps going to whatever line it wants. So I got to make sure I'm in the right thing. So notice I'm tracing up my absolute value, that my x value is getting bigger. I'm looking for my x values that are making this part of the function, and that's in the shadow of my x values here. So that's giving me this answer. Now, one last thing. This answer that I have here, this is a compound inequality. Okay, so I'm going to write this down. That's a compound inequality. Now, if I want to do set builder notation, I'm going to do curly bracket such that x is less than -3 or x is greater than 1. So that would be set builder. But if I want to do interval notation, okay, that gets a little trickier. So for interval notation, what I like to do to write my interval notation is I'm going to make a number line, and I'm going to put what my graph would look like. And we had gotten that from the calculator, right? Here, it goes out and it goes out on both sides. So -3 is here and 1 is here. Okay? So notice I have an open circle because it doesn't equal -3 and it doesn't equal 1. It comes really close. Way out here, if I keep going forever, I have the number -infinity, if you want to call it that. And way out here, if I could get there, I have the number infinity. So with interval notation, it's always a good idea to draw your x-axis if you're looking for x values and do this sort of marking. So I'm going to start at -infinity, not including. I'm going to go to -3, not including, or, okay, there's like a big pit I have to jump over here, and that's what that is. I'm going to start at 1, and I'm going to go all the way to infinity. So this is my interval notation right here. So that would be interval notation. So we have how we write it as a compound inequality, how we write it as set builder, and how we write it as interval notation.